Suppose we are given the question, given that the polynomial or the equation, in this case ax cubed positive bx squared positive cx positive d is equal to 0, and that their roots are in GP, that is geometric progression, and ABCD is not equal to 0. So we are given this polynomial p of x is equal to ax cubed positive bx squared positive cx positive d, and we are asked to find the condition when this polynomial will have its roots in geometric progression. So that is the another way to represent this problem. So solution, okay, let us assume that the polynomial has roots in GP, and let those roots be, so I'm taking the roots to be as alpha. Since a is already being used, I'm taking it as alpha divided by lambda, alpha, alpha lambda. Okay. Now you're free to use any symbols, but I'm using them. Now therefore sum of the roots taken one at a time. So that's going to be alpha divided by lambda positive alpha divided by lambda is equal to negative b divided by a. So negative b divided by a, it's already given as b, so there's nothing to change. So I can rewrite this as alpha of 1 over lambda positive 1 positive lambda is equal to negative b over a. Next, sum of the roots taken 2 at a time. Okay, so we are taking the roots 2 at a time. So if I were to do that, okay, first alpha over lambda multiplied with alpha plus, next I'm going with this alpha over lambda multiplied with alpha lambda. Next I'm going with these two, alpha multiplied with alpha lambda. This is going to be c over a. So if I were to rewrite this, it's going to be alpha squared divided by lambda positive alpha squared, okay, lambda gets cancelled here, positive alpha squared lambda is equal to c over a. Now if I take alpha squared out, this is going to be 1 over lambda plus 1 plus lambda is equal to c over a. So I will name it as 1, this one as 2. Now sum of the roots taken 3 at a time, or just say roots taken 3 at a time, or product of the roots taken 3 at a time. So that is going to be alpha over lambda multiplied with alpha lambda is equal to negative d divided by a. So this is going to be alpha cubed, lambda gets cancelled, giving you negative d over a. This is 3. So now what I'm going to do is I'm going to divide 1 by 2. Okay, 1 divided by 2. So that is going to be alpha of 1 over lambda plus 1 plus lambda divided by my 2 is alpha squared of 1 over lambda plus 1 plus lambda. This is negative b divided by a divided by 2 is c divided by a. So these two gets cancelled. So this is going to be giving me alpha with alpha squared. So 1 over alpha. If I were to rewrite this, negative b over a, if I were to flip this, it's going to be a over c. So a gets cancelled. So therefore we would have 1 over alpha is negative b over c. However, I can move this alpha this side. So alpha will be equal to negative c over b. Okay, so this is 4. So what I'm going to do, I'm going to substitute 4 and 3. So I will do that here. Okay, substituting 4 in 3, we get, so what do we get? So my 4 is alpha is equal to negative c over b. This is my 4. My 3 is alpha cubed is equal to negative d over a. So this would become, okay, so therefore 3 becomes, so negative c over b raised to the power 3 is equal to negative d over a. This is negative c cubed over b cubed is equal to negative d over a. The negative signs will become positive, so you can rewrite this by cross multiplying. So a times c cubed is equal to d times b cubed. So this is the required condition.